Welcome to our exploration of the different types of mechanical loads that act on the human body. Understanding these forces is essential for anyone studying biomechanics, physical therapy, or sports science. Mechanical loads are the various forces that our bodies experience during everyday activities, from walking and running to lifting and jumping. These loads can affect our bones, muscles, and joints in unique ways, influencing both performance and injury risk. In this video, we'll break down the main types of mechanical loads, explain how they work, and discuss their real-world significance. Let's start by looking at the basic types of forces that act on the human body and how they shape our movement and structure. First, let's talk about compression, tension, and shear, three fundamental types of mechanical loads. Compression is a pressing or squeezing force directed axially through a body, like the force your bones feel when you land from a jump. Tension, on the other hand, is a pulling or stretching force, also directed axially, such as when you hang from a bar and your muscles and tendons are stretched. Shear is a bit different. It's a force directed parallel to a surface, which can cause parts of a structure to slide past each other. Each of these loads acts differently on our tissues, and understanding them helps us appreciate how our bodies handle stress and strain during movement. Let's look at some visuals to see these forces in action. Now let's dive into the concept of stress as it relates to mechanical loads. In biomechanics, stress is defined as the force per unit area over which the force acts. It's a key concept because it helps us understand how forces are distributed within our tissues. For example, the lumbar vertebrae in your lower back bear more weight than the thoracic vertebrae in your upper back, but they experience less compressive stress because their load-bearing surface areas are larger. This means that not just the amount of force but also the area over which it's spread determines how much stress the tissue experiences. This principle is crucial for understanding injury prevention and the design of supportive equipment. Beyond the basic loads, the human body also experiences more complex forces like bending, torsion, and combined loading. Bending occurs when there's asymmetric loading, producing tension on one side of a bone and compression on the other. Torsion is a twisting force around the body's longitudinal axis, like when you wring out a towel or twist your ankle. Most real-life movements involve combined loading, where more than one type of force acts at the same time. This is the most common scenario for our bodies, as we rarely experience just one type of load in isolation. Understanding these complex loads helps us appreciate the resilience and adaptability of the human body. Wrap up: mechanical loads are a fundamental part of how our bodies move and function. From compression and tension to shear, bending, torsion, and combined loading, each type of force plays a unique role in shaping our movement and maintaining our structural integrity. By understanding these concepts, we can better appreciate the complexity of human motion, design safer training programs, and develop strategies to prevent injuries. Whether you're a student, athlete, or healthcare professional, knowing how these forces work is key to optimizing performance and health. Thanks for joining us on this journey through the world of biomechanics.